Welcome to Study Loop.
This is the answer to Chapter 17, problem number 67 from the Smith Organic Chemistry textbook. And this problem asks us to consider triphenylene and phenanthrene. And so we're asked to explain why triphenylene resembles benzene and that it does not undergo addition reactions with bromine, but phenanthrene reacts with bromine to yield the addition product drawn in the problem. And we're given a hint that the key here is going to be to draw resonance structures and then use them to determine how delocalized each pi bond is. Okay, and so I've drawn out skeletons here, and I've drawn the bonds in for the first triphenylene. And so I'm going to go through and fill the bonds in for the rest of them. I'm not going to show electron movement because we want to be able to see where the pi bonds are really well. Okay, and so in the first one, all that's changed is the leftmost ring. Okay, so that's the second one there, technically. All right, so then for 3, we're going to change them back. And then change the bonds in the top ring. So then for 4, we'll still be like this. And the top ring will have been changed back. And now we'll change this ring. So then for 5, we'll have this. And then, okay, so I'm going to delete this chapter 17, problem number 67. And hopefully that will give me the ability to move everything else up so you can see what I'm drawing. Okay, there we go. It's tight, but it does all just about fit. All right, so that's 1 through 5. So 6 is going to look like this. So basically, we're just switching the bonds around in the rings, in the aromatic rings. Okay, so that's 6. 7 is going to look like this. Okay, 8 will look like this. And then in 9, we finally get some double bonds into the center ring. So 9 is going to look like this. Okay, so there we go. So basically, triphenylene here is going to act like benzene because really in 8 of the 9 resonance structures that we've drawn here, they are each of the rings is acting independently as a benzene ring. They're all just joined by this central ring. And again, the very last resonance structure doesn't have that form, but otherwise, it's really just 3 benzene rings joined together. So that's why they're going to each act like a benzene ring. The other way that you could think about this is each carbon-carbon bond in triphenylene has 4 or 5 resonance structures in which it is a single bond, and 4 or 5 resonance structures in which it is a double bond. So roughly half and half. And what we're going to see when we do phenanthrene's 5 resonance structures is that that's not the case for one of the double bonds in phenanthrene, or for rather two of the carbons, one of the double bonds, however you prefer to think about that. So that's triphenylene there. So then here's phenanthrene. Again, I've drawn the first one. So for the second one, we're just going to move some bonds around. Okay. Then for the third one, it's going to look like this. Well, that's not right. It's going to look like this. Sorry. Oh, no, I was right the first time. Okay, sorry. Let's try that one more time. So the third one is going to look like this. Okay. The fourth resonance structure will look like this. And then the fifth and final resonance structure will look like this. Okay, and so what we see here is that there are two carbons that 4/5 of the time here, in 4 out of these 5 structures, there's a double bond here. And so while the other carbons are, relatively half double bond and half single bond, these two carbons, the majority of the time, have a double bond between them. And so when we look at the problem, that's the double bond that's going to be brominated. And so everything that I've green arrowed there is going to have much more double bond character than the other carbons in phenanthrene. And so that's why they're going to undergo addition rather than substitution, because they have more double bond character. And again, that's because 4/5 of the time there is just a double bond there. And so it's not, those electrons are not as delocalized as we would expect, given that this is a 3-ring aromatic system. Okay, and that's the answer to chapter 17, problem number 67.